Okay, welcome to part 2 of the video. Again, I said we left off, I said we're going to go over the questions to answers to questions pages 5 and 3 to page 5. They're all questions on metals. Alright, so let's go over them. Number 1, the majority of the elements in the periodic table are metals, choice 1. Right? Again, I said the left 2/3 of the periodic table are metals. Number 2, what can be concluded if an ion of an element is smaller than an atom of the same element? The answer should be 3. The ion is positively charged because it has fewer electrons than the atom. Okay? So again, the ion is smaller than the atom, and that's true for all metals. Right? Remember I said yesterday, in metals, the atom is bigger. Okay, so in this case, here's your metal, sodium, there's the atom, and here's your ion. When it forms an ion, it lost 1 electron, so therefore it's smaller because it has 1 less shell. Okay. Number 3, when an atom becomes a positive ion, the radius of the atom did what? The radius decreased, choice 1. Number 4, which group 14 element is classified as a metal? So if you'll come over to here. Here's group 14. Remember I said metals are located to the left of the staircase. So here's your staircase. So what element in group 14 is to the left of the staircase? Alright, so it looks like tin, Sn, is to the left of the staircase, so that is the correct answer, choice 4. Okay, the other 3 choices are not to the left of the staircase. Alright, so tin. Okay, page 4. What occurs when an atom loses an electron? Right, back over here. What occurs when an atom loses an electron?
4:40 and all is well. Please remember, the building will be closing promptly at 6 p.m. Please make sure you have plans to get home safely by 6 p.m. Thank you much.
Alright, the answer would be 2. The atom's radius decreases and the atom becomes a positive ion. When you lose an electron, it becomes a positive ion and the radius decreases. Choice 2. 6. In general, the elements with lowest ionization energies will be classified as 3 metals. Alright, if you look down here, the ionization energies, the ones with the lowest ionization energy are metals, all on the left side of that staircase. 7, an element that is malleable and a good conductor of heat and electricity could have an atomic number of, choice 3, 29. Yeah, look for a metal, anything to the left side of the staircase, so it would be 3. Number 8, which change occurs as a cadmium atom, Cd, becomes a cadmium ion, Cd2+. So it went from normal to positive 2. Just like Na goes from Na to Na+1, Cd goes from Cd to Cd+2. So if it went from Cd to Cd+2, you must have lost 2 electrons, so it's 3. The Cd atom loses 2 electrons and its radius, of course, decreases, 3. Okay, 9. An atom of an element has a total of 12 electrons, and an ion of that same element has a total of 10 electrons, which statement describes the charge and radius of the ion. Okay, so if the atom has 12 electrons, so atom has E equals 12, the ion has 10 electrons, that must mean it must have lost 2 electrons. Okay, and if it lost, it must be smaller than the atom, right? If you're losing, this must be smaller than that. Okay, so the answer would be 1. The ion is positively charged, and its radius is smaller than the radius of the atom, right? It'll have a positive 2 charge. Okay, choice 1. Number 10. We're going to skip number 10. We're going to come back to that in a later time. It should have been put on this page. So skip number 10 for now. We'll come back to that at a later date. 11. When an atom loses an electron, its radius generally 1 decreases, gets smaller. Number 12. A sample of an element is malleable. That means metal, and can conduct electricity, which means metal. This element could be, again, look for the left side of the staircase. The only thing on the left side of the staircase there is choice 4, Sn. And 13, which 2 characteristics are associated with metals? Choice 1, low first ionization energy and low electronegativity. They want to lose, so it takes very little energy to pull away electrons. That's low first ionization energy. And they don't want to gain electrons. That means they have a low electronegativity. Okay? Remember, metals left, low, lose. Right? So they're both low. 14, an element that has a low first ionization energy and good conductive heat and electricity is classified as a 1, metal. And 15, which element is malleable and can conduct electricity in the solid phase? Again, look for metal on the left side of the staircase. Choice 4, tin. Okay, now for the short answers. 16. Describe 1 appropriate laboratory test that can be used to determine the malleability of a solid sample of an element at room temperature. Okay, Malleable, remember, means malleability means the ability to be hammered into sheets like my file cabinet. So the answer to the question would be, see if it will hammer into sheets. Okay, and make sure it doesn't break. If it breaks, then you know it's not malleable. So see if it will hammer into sheets and make sure it doesn't break. That's the best answer for number 16. Okay. Okay, 17. Again, we're going to come back to these comparing size of atoms and ions a lot in these questions. 17. Explain in terms of atomic structure. In terms of atomic structure, the structure of an atom, like I have on the board here. In terms of atomic structure, why cesium has a lower first ionization energy than rubidium. Okay. Why does cesium have a lower first ionization energy than rubidium? All right, if we come over here, cesium's in group 6, rubidium's in group 5. Cesium's in period 6, rubidium's in period 5. So cesium has 6 shells, rubidium has 5 shells. Remember, as you go down, the more shells you get. So the more shells you have, the easier it is to pull an electron away, the lower the ionization energy. So that's why, because cesium, in terms of atomic structure, cesium has 1 more shell than rubidium. So if you have more shells, you're going to have a lower ionization energy, it's going to be easier to pull an electron away. So the best answer would be because cesium has 1 more shell than rubidium. Right? And the more shells you have, the more loosely held the electron is, so the smaller amount of energy it's required to pull it away. Okay, okay, 18. After reading that little passage, it says, explain why the radius of a positive ion of element M is smaller than the radius of an atom of element M. Same reason. Why? Why is the radius of a positive ion smaller than the radius of an atom? Because the ion will have 1 less shell than the atom. Again, because the ion has 1 less shell than the atom because of lost electrons. When you form a positive ion, you lose this 1 electron here, so you have 1 less shell now. Now you have 2 shells, this one has 3 shells. So when you form a positive ion, you lose an entire shell. So the ion is smaller because it has 1 less shell than the atom. Okay, and 19, after reading the reading passage, it says, explain in terms of atomic structure again, why a potassium ion is smaller than a potassium atom. Same reason. Potassium atom is 2881, and potassium ion, you lose that 1, so now you only have 3 shells, 288. So, ask you why is the ion smaller than the atom? Because it has 1 less shell. Number 20, explain in terms of electrons why the radius of calcium ion is smaller than the radius of a calcium atom. Again, because it has 1 less electron shell. And 21, 1 electron is removed from both an NaM and a K atom, producing 2 ions. So now we're down to Na and K, 2 different elements. Okay, so Na is 281, K is 2881. It says 1 electron is removed from both, so now you have 28 and 288. So explain why the Na ion is much smaller than the K ion. Okay, why? How many shells are in the Na ion? 1, 2. How many in the K ion? 3. 1, 2, 3. So therefore, it says why is the Na ion much smaller than the K ion? Because it has 1 less shell. That's why. Alright, and 22. Notice the trend here. State in terms of the number of electron shells why the radius of a strontium atom in the ground state is larger than the radius of a magnesium atom in the ground state. Okay. Magnesium is 282. That's 3 shells. Alright, strontium, I believe, is 2, 8, 18, 8, 2. So that's 5 shells, right? So strontium has 5 shells, 1, 2, 3, 4, 5. Magnesium has 3 shells. So strontium has more shells than magnesium is the best answer for that. You don't have to put the specific number of shells. As long as you put SR, strontium has more shells than magnesium. That's the correct answer. That's why strontium is much larger than magnesium. It has 2 more shells. Okay. Alright, so now that is everything about metals. Okay, so now today, this lesson, we're going to move into nonmetals. And if we have time, we'll get into metalloids. So nonmetals is the total opposite of metals. So come over here now, like I mentioned yesterday. Here's your staircase. Everything to the left side of the staircase is a metal. So that means everything to the right of it is a nonmetal. So everything to the right of this staircase here is a nonmetal. The only exception is hydrogen. Hydrogen all up here by itself is also a nonmetal. So hydrogen and everything to the right of the staircase is a nonmetal. So number 1, you're going to write located to the right of the staircase on the periodic table. Located to the right of the staircase on the periodic table. Okay. so again, everything for non-metals should be the opposite of metals. So let's take a look at some of the non-metals here. O, F, S, C, L to the right of the staircase. Remember, notice everything yesterday to the left had positive ions. What does everything to the right have on the top? Negative ions. So if they have negative ions, does that mean they're losing electrons or gaining electrons? It means they're gaining electrons. So when O wants to gain 2 electrons, it's 2-6, it wants to gain 2 to become 2-8, so it wants to gain electrons. Alright, so nonmetals tend to gain electrons, which is the opposite of metals, which tend to lose electrons. And if they gain electrons, they tend to form negative ions, whereas metals want to lose electrons and form positive ions. So nonmetals tend to gain electrons and form negative ions. So number 2 is going to be tend to gain electrons and form negative ions. Number 2, tend to gain electrons and form negative ions. Now for number 3, look over here. In a metal which is bigger, the atom. Why? Because when a metal forms an ion, it loses an electron, 1 or more electrons, so the radius becomes smaller. Okay? In a non-metal, that's going to be the opposite. Remember here you have atom, metals, atom is bigger. So the same thing, easy way to memorize it would be ion. The last letter in ion is N. The first letter in non-metal is N also. So that's how you memorize non-metals. Ion is larger than the atom. Okay? So number 3, you're going to write in a non-metal, the ion is larger than the atom. And then you can add that to number 3 also. In a non-metal, the ion is larger than the atom. You put ion, non-metal, circle the ends to note that non-metal ion is bigger. Alright? Alright. However, even though it's bigger, it's still got the same amount of shells. Metals, you have different numbers of shells. Metals, you lose a whole shell. Non-metals, when you gain electrons, you're still going to have the same number of shells. You just have more shielding, what's called more shielding. You're not going to be responsible to know why the ion in non-metal is bigger than the atom. But for metals, you definitely know the atom